Earth is in between, and the moon moves this way, then you notice this phenomenon that the moon rotates for some time, and it happens slowly. So it's very natural to connect that if you have a light source here, and it's touching an object, but you are coming in between, and this object is moving, you're blocking it for some time, and then again, it's coming into view. So that means this darkening of this guy you're seeing is because my shadow is falling on that. So that much you can deduce, right? Now look at the shape of the shadow. The shape of the shadow would be the shape of the object. So if the Earth is in between, and the shape that you're seeing on the Earth of the shadow is round, it's not straight, it's round. So what do you conclude from that? Spherical. So this is what you observe. And look at the conclusion. I mean, imagine when people didn't know if Earth is even flat. From that, you get to the conclusion by this observation that people had for centuries. And then connecting this logical analytical mind, connecting that from the shadow you can deduce the shape of the object, and it's telling me that we are not flat, some rectangle, cuboid thing, we are a sphere. That was an observation. So this figure is telling you that. So is the logic clear, everybody? If you have any questions, I'm not saying that I suddenly know the answers, but just ask. Maybe somebody else would know, or we will figure it out. Okay? So if there are any questions, any confusions. So I said all these things, so I'm flashing really quick. So you can see in the figure also the shadow, how it's not like straight, it's always a kind of curved thing. Okay. Another observation here is, so over the years, the stars that are very far away, they look at the same position all throughout the year. But then there are certain stars that are visible from one position of the Earth and not in the other position of the Earth. So how can that happen? So that can happen. So first of all, it's consistent with the geometry of the sphere that something will be visible to you, but not so. That's here. Something very far away could be that it's visible if you're living here, but if you're living here, then it's not visible to you because light will never come, and Earth is doing that. So you don't even know which way Earth is going, but you can deduce that. It must be that it's a finite thing. It's a finite surface, it has a curvature. But this can also lead you to calculate the radius of the Earth. So how? Oh, I think he didn't do it. So this was 200 BC. So that's about 322. So 2,500 years ago. So this guy is some Greek name, Redhoff Kinesis. How do you pronounce it? Have you heard of him before? Yes. You have? Where? In mathematics? Oh yeah, let's talk about it. So we computed the radius of the Earth about 7,000 kilometers. So how did he do that? So try to understand the geometry here. So now I'll go slow here. So there was a whale in Egypt, and from now we know it's on the Tropic of Cancer. So the sun is on certain day. Sun is exactly on top of there. But you don't have to know all that. you can just, if you're living there, you could observe that I have this well, and there comes a day every year that the sun is directly on top of the well, so you can see the whole sun in the well. That observation you can do. So he learned of that from somebody. So this is the place in Egypt, in the where the red arrow is pointing, and that's where the well was, where the sun was exactly on top. And now we would say, because it's on top of the cancer, the sun was directly overhead. But then, if you do the same thing in here, well, it's also in Egypt, in Alexandria, then say you have a well in Alexandria too, then sun doesn't come all the way, so you don't get the whole image of sun in the well anytime you're in the area. Because sun is at an angle, so let me show you the geometry. Here. So what is saying, so this place you should think of here, and this place, because this is round, it's like going that way. Okay? Sun is coming straight here, but here it's coming straight, but the normal to the sphere is now at an angle. So if you are locally there, you will never see sun exactly on top. It will be at some angle. Is that quite clear, everybody? So the question is, what is that angle? So that angle you can measure to be 7 degrees. So you just take the normal, we had comparison stuff. So you have normal, you just see how much you have to go to see which way the sun is. Because you can see its image in the well. So that was 7 degrees. And you know the distance between the two places. In this case, it's Syene, Alexandria. That's about 750 kilometers. So from that data, the distance between two places, the angle that the sun is making at one place is exactly overhead, another place is coming at an angle, and the distance between these two places. Can you deduce? Can you calculate the radius of the Earth? Yes or no? What would you do? You know this distance and you know this angle. This angle is the same as this angle. Yes. Are you able to see? So here, I'm assuming that this is that place in Egypt and another is in Greece. Here the sun is coming this way. Here the sun is coming this way. So this angle you can measure. That's 7 degrees. But if the Earth is sphere, geometry tells you these two lines are parallel. So this angle is same as this angle. So this is 7 degrees. Yes? And you know this distance. Let's call it d. Small d. I'm sorry, there's not enough space, so I cannot draw it bigger. But if it's not clear, tell me. Or if you draw it on your own, then you should be able to see the geometry. So if you know this distance and you know this angle, can you calculate the radius? Yes. Yes. How?
Theta by 15 divided by r is equal to that distance.
Good. So angle is equal to r upon radius. So angle is 7 over 5. R is d. Radius is r. So you can solve this for us. Clear, everybody? Again, simple observation, huge results. So that's what he did. whatever the answer is, I don't know. Oh, around 6,000 something kilometers, right? Radius of the Earth. So now we have an estimate of the radius of the Earth. So far so clear? Okay. So that's the first. Now you know the how big our planet is. Now we come to the second part of the cosmic distance ladder, and we want to know how far away the moon is and how big it is. So what can we do? Any ideas? Now, at least the thought process is clear to you that you need to keep your eyes open, look for the phenomena, look for some uniformity, then use geometry. So what should one look for? If you want now to measure the size of the moon and the distance of the moon from Earth, then what should we be looking for? Does anybody know how to do that? So the first observation again was done by Aristotle, who said that if you look, so this is the observation that tells you that moon is a sphere and it's not a disk. So far you just seen this object and you see, if you know any of this, when you look at moon, you always see one side of the moon. So you don't know that it's round, it's this thing is a sphere. All you know is that it might as well be a disk. You don't have Newton's laws, so you don't know anything about the gravity and all this. But here's the thing. If earlier we said that the eclipse is happening because of the shadow of Earth. Now, if it were a disk, then the shadow would be like a circle. See what I'm saying? So if moon were a disk, and you look at the shadow, then it would be like a circle. Part of circle line. But now if you think that moon is a sphere, then it's like it's a bulge. So what you will see from here is not like this, but something like this. Like a part of an ellipse instead of a circle. And that is enough to conclude that the object you are looking at is not a planar disk, but a sphere. Does that make sense? So from that, you can conclude. These are the images. I don't know if you can tell it so well. Here, for example, especially when it's like up the point, there's a difference between what a circle would look like versus what an ellipse looks like. So from that, you can conclude that the moon is always spherical in shape. Now, Aristarchus measured the distance of Earth to the moon, and his answer was about 60 times the radius of the Earth. So radius of the Earth is already known now to us because we have done the first ladder, the first step of the first rung of the ladder. So let's see how Aristarchus measured or calculated or estimated